Now let's see the concept of lattice. So there are three types: join semi-lattice, meet semi-lattice, and lattice. Now if you take the poset, and for every pair, if least upper bound exists, then it is called as join semi-lattice. If least upper bound exists for every pair of elements in the poset, then it is called join semi-lattice. And meet semi-lattice is if greatest lower bound exists for every pair of elements, then it is called as meet semi-lattice. And lattice is if it is both join and meet, then it is lattice, which means if both least upper bound and greatest lower bound exists for every pair of elements, then it is called lattice. Okay, how to remember this one is, we know that join is also called as least upper bound. That is why if least upper bound exists for every pair of elements, then that is called as join semi-lattice. And we know that greatest lower bound is also called as meet. That is why if greatest lower bound exists for every pair of elements, then it is called as meet semi-lattice. Got it? So why is it called semi is the property to be satisfied to become a lattice is only half fulfilled. If you have to become a lattice, you have to be both join as well as meet, and since it is only half fulfilled, we are calling it as a lattice. Got it? So semi-lattice. Okay, so with examples it will be even clear. We shall see the examples now. See this one, capital A equal to 1 2 3 4 5 6 so on 10, which means we have 10 elements here. Then they are saying that A comma divides, so it is a set, and then relation is defined on that, and this relation is partially ordered relation, therefore it is a poset. Now this poset is meet semi-lattice. Okay, don't get confused here. So how did we build the concept is, initially we talked about this set and then Cartesian product, right? And the subset of Cartesian product is nothing but a relation. Now if a relation happens to be reflexive, antisymmetric and transitive, then we call such a relation as partially ordered relation. Now a set along with the partial order relation, this is called as poset, right? And now we are talking about when a poset is going to be a lattice, right? So a poset can be meet semi-lattice or join semi-lattice, or it need not be anything, right? And if it is both meet and join, then it is going to be lattice. Okay, don't get confused here. Now they are saying that we have a set 1 2 3 4 5 6 7 so on 10, and divides is the relation defined on that in such a way that A comma divides is a poset. Then they are saying that it is meet semi-lattice. Why is it meet semi-lattice? See this. So when is it going to be meet semi-lattice is if for every two elements, for every pair of elements, if there is greatest lower bound, then we can say that it is meet semi-lattice, isn't it? Now if you take 1 2 3 so on 10, you take any two elements and you try to find the GCD. Greatest lower bound is nothing but GCD, right? In worst case, the GCD is going to be 1, isn't it? And otherwise you'll get some other GCDs. Got it? Therefore for every two elements in this set, you'll definitely be able to find the GCD, which means for every pair of elements there is greatest lower bound. That is why it is meet semi-lattice. Now it is not join semi-lattice. The reason is, for any two elements if you take, the LCM should be present in this set, but LCM will not be present. You can see one such example. For example, if you take 3 comma 4, these two elements, and if you try to find the least upper bound in this case, in this type of relation, is nothing but LCM. If you try to find the LCM of 3 comma 4, it is 12. But in this set we have only till 10, which means we have found a pair for which least upper bound does not exist. So it cannot be join semi-lattice. Since greatest lower bound for every pair exists, it can only be meet semi-lattice. Therefore this is true, right? So the set A and divides is meet semi-lattice, and it is not join semi-lattice, and so it is not a lattice, it is only meet semi-lattice. Got it? Now let's see this set. So this set is given as set of 3 sets, and we have a relation defined on it, which is set inclusion, which is nothing but subset. then they are saying that it is joint semi-lattice. So what do you mean by joint semi-lattice? If you take any two elements, then the least upper bound should exist. So what is least upper bound in terms of this subset operation? It is nothing but union. So you take any two elements and you find the union that will definitely be present in this set, which means we are going to have least upper bound for all the elements, right? In fact, we have only 3 elements, therefore we are going to get 3C2, which is nothing but 3 pairs. Either you take these two or these two or these two. If you find out the union, the result is going to be present in this same set, which is of course this one, isn't it? Therefore, for every pair of elements in this set, we are going to have the least upper bound. Therefore, we can clearly say that in this particular example it is joint semi-lattice. Now, why is it not meet semi-lattice? What is greatest lower bound in terms of sets? It is intersection of two sets, isn't it? Whenever the relation is subset. See, only when the relation is subset, then only you have to take union and intersection. If the relation is different, then we have to change it. Okay. So now if you take any two elements, for example, if I take these two elements, what will be the greatest lower bound? It is nothing but intersection of these two elements, which is phi. Since phi is not present here, so for every pair of elements there is no greatest lower bound. That is why it cannot be meet semi-lattice. So only thing is it can be joint semi-lattice. Even if you try to put this one in a diagram form, you are going to get A here, B here, and then AB here, right? Therefore, for these two elements there is least upper bound, but then there is no greatest lower bound, right? They are not meeting anywhere. That is why it is not meet semi-lattice. Why? Because these two elements it failed. But then for all pairs of elements, since there is upper bound, it is joint semi-lattice. Now see this one, A equal to 1 2 3 4. We have 4 elements here, and less than or equal to is the relation. Now if you try to put it in form of the lattice, you will definitely see that it is a chain 1 2 3 4, right? And we know that for less than or equal to relation, a minimum of 2 elements is going to be the greatest lower bound, and the maximum of 2 elements is going to be the least upper bound. Therefore, for every pair of elements, one of them is going to be the least upper bound and one of them is going to be the greatest lower bound. Therefore, we can directly say that both the GLB, greatest lower bound, as well as least upper bound exists for every pair of elements. Therefore, it is a lattice. So one interesting thing is, if you have a total order like this, which means a chain, that will always be a lattice. The reason is, you take any two elements, one of them is going to be greatest lower bound and other one is going to be least upper bound. Therefore, it is going to be both joint and semi-lattice. Joint semi-lattice and meet semi-lattice. So we can say that it is lattice. So this one is definitely a lattice. So we have given only few examples, but as we move on, I'll give you even more examples. With those examples, this concept will be even more clear. Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year and in India the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.